On behalf of the project team, we thank you for your time and interest in the Lower Clear Creek and Dickinson Bayou watershed study. Tonight's focus is on the Dickinson Bayou watershed. My name is Chuck Wolf, and I am the Freese-Nichols Project Director. The overall goal of the public meeting is to provide more information and an opportunity for you to comment about the study progress and propose concepts to address the flooding in the Dickinson Bayou and Clear Creek watersheds. This is why we are here tonight. We want to hear from you about the issues you would like for us to address, and we appreciate everyone taking the time to join us this evening. Our agenda for the meeting is should be presented on the slides. Before we proceed with our agenda, I would like to acknowledge the project team members in attendance tonight. So from the City of League City, we have John Baumgartner, who's the City Manager for the City of League City. We have Anthony Toludo, who's the Project Manager for the study from the City of League City. From Freese-Nichols, we have myself, as well as Brian Gettinger, who's our Project Manager, and Jim Keith, who's our Technical Lead. From Holloway, we have Rachel Massey and Connor Stokes, who are going to help us with facilitation. From RPS, who's also leading the Galveston Master Drainage Plan, we have Luis Partita, who's their technical lead, as well as Natalie Weyerhausen, who's their project manager. And then from LJA, who's working with the City of League City on the city's drainage plan, we have Georgina Aurelio, who's the project engineer, and John Grounds, who's the technical lead for that project as well. So John Baumgartner is going to, the city manager for the City of League City, will provide some opening remarks as part of the agenda, followed by a presentation about the project from the Lower Clear Creek and Dickinson Bayou Watershed Study Team, and updates on work performed by partner projects with the City of League City's Master Drainage Plan, as well as Galveston County's Master Drainage Plan. Following the presentation, you'll be provided with the opportunity to present comments and questions to the project team. For individuals who have only called in through the phone, you have the option to submit written comments through mail. We'd ask you to send those to attention LCCDB Study Team, care of Holloway Environmental Plus Communications Incorporated, 2500 Summer Street, Suite 1130, Houston, Texas 77007. Or if you'd like, you can use the comment form or the online form through the project's webpage. That's www.leaguecity.com/LCCDB. So once again, it's www.leaguecity.com/LCCDB. And with that, I'll turn it over to John Baumgartner for some opening remarks.
Thank you, Chuck. It's a pleasure to be here tonight. It's interesting times we're all going through, trying to learn about remote meetings and virtual meetings, and I see we have great attendance, 46 people attending right now, and just wanted to express my gratitude to all the folks participating remotely. It's a challenge. It's a challenge for us to get information out. I think everyone recognizes it's been 3 years since Harvey. It's been 2 years since Council said, Baumgartner, pick up this project and take a look at our major bayous and see what we can do to help reduce flooding throughout the region. This wouldn't be possible, certainly without our technical team, including RPS and Holloway and Freese-Nichols, etc., and obviously the Army Corps of Engineers, both as a technical partner as well as a financial partner. And then in the Dickinson Bayou watershed, lots of financial partners: Galveston County, certainly Dickinson, City of Dickinson, Brazoria County, Army Corps of Engineers, Friendswood, and Pearland, and a host of others that have made this project possible, have stuck with us. I think we gave Freese-Nichols the approval for the contract in November a year ago, and so we're almost 12 months into an 18-month project. We've had a couple of meetings, and so we're continuing that, and look forward to the information Freese-Nichols and RPS is going to share tonight. So with that, welcome everybody. Thanks for being here, and back to you, Chuck.
Okay, Brian, you want to take us to the project background?
Brian probably needs to unmute.
Oh, thanks, guys. I am unmuted myself, then unmuted myself again. If you don't ask somebody to unmute during a call these days, it doesn't count as a real call. So appreciate it. I'll take that one for the team. Thanks, John. Thanks, Chuck, for getting the stage set there. We've working on this study for, as John noted, just about a year, and I think we spent quite a bit of time getting all the ducks in a row ahead of that. We're honored to represent City Lake City and the other study partners on this project. Appreciate everyone that attended the meeting tonight, taking time to listen and find out more about the project. We have a lot of participants on the phone. We've had a lot of participants in the process so far. We're excited to hear more from you guys today. So a little bit about the purpose and where we've come from. Purpose of the study is to develop a comprehensive flood mitigation plan for Lower Clear Creek and Dickinson Bayou watersheds. That includes identification of vulnerabilities in the watershed and development and refinement of concepts that are going to reduce flooding. We've moved quite a ways on the road. We'll talk about what we've done so far and what we have to do in the future on this project. But we're making great progress. And at the bottom line, in short, the goal here is to reduce flood risks by improving conveyance in Dickinson Bayou, particularly here, and also in Clear Creek. Those improvements are going to make all the local drainage project systems work better as well. Go on to the next slide. So as John and Chuck referred to earlier, this project is called the Lower Clear Creek and Dickinson Bayou Watershed Study. We are focused on both of those watersheds, which makes up a large area of the Southeast Houston region. Dickinson Bayou particularly as a focus this evening, predominantly in Galveston County, a little section there in Brazoria County. We are focused on the entirety of the watershed and mostly focus on the main channel of Dickinson Bayou and how we can get that flow out to Galveston Bay more effectively. Focus on structural improvements within the Galveston County area. You want to the next slide? So we'll have another meeting next week on Clear Creek. You jump back to the previous slide there. Another meeting next week on Clear Creek, which, as you can see on the map, has got a few different colors, breaking that apart. Dickinson Bayou is a little less complicated as far as who is working on the project. We'll talk a little bit more later with information from the Galveston County and their consultant RPS on the mainland Galveston County drainage study, which is sponsored by the GLO. But again, next week at 6:30, same on Wednesday, we'll have a discussion on Clear Creek. So if you want to hear more about that, call back in. Tonight's focus is on Dickinson. On the next slide. So obviously, we're here today in part because of the impacts from Hurricane Harvey in August 2017. It's hard to believe it's already been 3 years, and many things have been happening since then. Our goal is to get these studies done so we can start turning dirt and prevent those flood damages from happening again in the future. We had never before seen precipitation amounts in the region, record high water surface elevations in Clear Creek and Dickinson Bayou, and widespread flooding in both rural and municipal areas. So one of the first steps of this project was delineating the watershed. So delineation is a fancy engineering word for determining which way the water is going to flow when it hits the ground. So does that water flow into Dickinson Bayou, or does it flow into Clear Creek? That's really important to know when we're looking at modeling and how much flow and how deep the flow is. It's also very challenging, unlike in the Rocky Mountains where there's a big mountain range and water on one side goes one way and the other side goes the other way. The whole area east of I-45 is pretty flat. In some cases, roads actually act as the delineating factor between one way or the other. You can see that from Highway 3 kind of in the middle of the page. So this is kind of the first step, delineating the Dickinson Bayou watershed, making sure we know which way the water is going to flow. And so we've done that, looking at new LiDAR topography data. So we have a clear identification of this is the entirety of Dickinson Bayou. Go on to the next slide. Also, going through what we've done in the past, we were fortunate that we had our first round of public meetings immediately before everything started to get shut down with the coronavirus. So we appreciate the feedback we got. We got a lot of discussion. We had 4 different meetings. I assume some of the folks on the phone tonight will probably participating in those meetings as well. We appreciate your continued participation. We've incorporated your feedback into the concepts and the modeling that we've done. We hope to get more feedback from you tonight. The meeting for phase 1 was all about listening. Tonight's meeting is about presenting what we've done and also listening. And then we'll have a third meeting in the spring, that's going to focus on what we concluded with the study. On the next slide. So project timeline, where are we at? The original schedule had us completing the project in May of 2021. We've heard from the public, and every time we've had a conversation, that we need to get things done faster. And so we've bumped up that project schedule a couple months into March, and we've done that in part by working in parallel between what we're calling Phase 2, which is our watershed study and modeling, which we're going to talk a lot about today, and then Phase 3, which is the project identification. So we got an early start on Phase 3, working in parallel. And that way, when our modeling is complete, which it just about is, we have things that we can plug into the models immediately, or they're already developed, and we can start evaluating their effectiveness. So we'll talk a little bit tonight about some of those concepts and some of the ideas we're thinking about to get your guys' feedback on. But most of the focus tonight is going to be about that Phase 2, the watershed study. All right, on the next slide. So what have we accomplished? So preliminary concepts that have been developed, including incorporating concepts that were put together by others. We do not have a monopoly on good ideas, and so if there are good ideas out there, we're happy to include them in the analysis of the study. So as Chuck noted, there's lots of ways to get engaged with us. One of them is through the Q&A function here, the website, by mail. I think at this point we have a project email as well. Please reach out to us. We're open to new ideas and happy to evaluate those as part of the project. We worked on developing non-cost factors for the alignment evaluation. So some of the things are pretty cut and dry. You know, how much flood damage is reduced and how much does the project cost. But there's also other factors that affect how much community support a project will get, how easy it is to permit, for example, and how much land that has to be acquired. Those things all have some cost implications, but we want to talk about how those affect the projects we're going to go forward with. Talk about that a little bit later. We also have initial modeling for Dickinson Bayou's main stem complete, and that work's been done primarily by RPS, and we'll have a presentation by them in a few minutes. We're going to do a heavy dose of quality control and quality assurance on those models and calibrating them. We want the models to be both precise and accurate. So when we say that we're running a 100-year storm through the model or we're running Hurricane Harvey through the model, we want to make sure that what it's showing us is actually what happened. And so some of your anecdotal comments about, you know, during this event, the water is this high here, that's been helpful for us to do that. Preparing to revisit the concepts and evaluate them with the new model. So we've mentioned that we started developing some concepts earlier this summer. We paused after that concept development started, and now that the modeling is done, we'll be able to push those concepts through the model, see what kind of benefits we can realize, how we can tweak them to be most effective. Next slide. So Chuck mentioned that, and John as well, that we have a lot of partners on this. Some of the partners are actually performing technical functions that benefit this project, and our project in turn benefits their projects. So the two ones we're going to discuss in more detail tonight is the League City Master Drainage Plan being performed by LJA and the Galveston County Mainland Flood Study being performed by RPS. So we've got representatives of each of those teams on the call, and first I'd like to have Georgina from LJA talk about the Master Drainage Plan.
Good evening, this is Georgina Aurelio from LJA. We are working on a master drainage plan for the city of League City. This plan is going to include all the channels and watersheds contained within the city. The goal of the League City Master Drainage Plan is to define existing baseline conditions for drainage infrastructure and identify potential future problems in the city, evaluate the severity and complexity of the problems and the potential solutions using city criteria, develop a strategy for the watersheds that provide improvements for future drainage infrastructure, create a comprehensive master drainage plan to document recommendations for required improvement projects, and develop detailed costs and implementation information for these projects. Next slide. This exhibit shows the study area and the tributaries that drain League City. Watersheds in the red and orange are part of the larger Clear Creek watershed, and watersheds in green are part of the larger Dickinson Bayou watershed. The city's drainage is split between these two major channels. LJA is currently studying the watersheds in the city as shown, as well as incorporating studies by others for Magnolia Creek, Cedar Gully, and Benson's Bayou. Major overlapping studies such as Galveston County Master Drainage Plan, Lower Clear Creek, Dickinson Bayou, and MapNext Flood Insurance Study will be referenced in our own study. We will compile all these findings within the watershed improvement strategy and recommendations for required future projects.
Awesome. Thank you, Georgina. Appreciate your update on that. With that, we're going to talk a little more detail about what we're doing in phase 2, which is really focused on hydraulic modeling. So the next slide shows a couple important definitions that we want to go through. Again, engineering terms that are thrown around a lot on calls like presentations like this, that we want to make sure everyone understands what they are. So hydrology represents the quantity of water that's generated within a specific area or watershed. So when it rains 12 inches in 24 hours, we're talking about hydrology. Hydraulics deals with calculating the depth of flow in open channels and other methods of transportation. So how is the water, when it hits the ground, making its way out to Galveston Bay? That's hydraulics. And so we're talking about a little bit of both things. And at this point, I want to invite Jim Keith, our technical lead for the project, to talk a little bit more about how those general hydrology and hydraulics terms apply to the Dickinson Bayou watershed.
Thanks, Brian. So I'm just going to set the stage for some of the H&H work that you're going to see later on as RPS presents on Dickinson Bayou. So the whole purpose of H&H modeling is really to help accurately identify flood risk within a watershed. And typically how you might have seen that is a line on the map that kind of horizontally depicts the extent of the floodplain. What you see here is a graph that also shows you the depth of that water. And so you're going to see this later on, and that's why we want to kind of explain what you're looking at. This sort of heat map where these warmer colors that go from yellow, orange to red represents deeper water during a given flood, and then the shallower flood depths are kind of in the blue color range. And so what this does again is just kind of help us understand the flood risk in a given area and what that means. You can go to the next slide, please. The other important factor that we used in this study, or that we're using in this study, is the latest rainfall data for Texas that has been developed by the National Oceanic and Atmospheric Administration called Atlas 14. You may have heard a fair amount of talk about Atlas 14, but that's the best available rainfall data that's been developed. And one of the big changes that was shown out of that study was an increase in rainfall depths, primarily in the southeast and the Houston area, as well as central Texas. So that rainfall data has been adopted pretty much across the state, and it's definitely being used by Harris County, by Galveston County, as they develop new flood risk products. You can go to the next slide. So when we talk about 2D modeling, this is just kind of a snapshot to help you understand what's going on. And we're not going to get too far in the weeds on this, but we want to give everybody kind of a visual representation. Typically, in older studies, maybe that have been done by FEMA in the past, use kind of a one-dimensional approach and cut cross sections across an entire floodplain. And that assume that all the water is going in one direction. And here now we have some better modeling tools that have been available in the past few years, where we can still model in this channel area, in the main channel where we know that flow is actually kind of all going in one direction downstream. But as that flow spills out of the channel into the overbanks and the floodplain areas, as all of you well know, that water can go in a number of different directions. It goes down streets, it goes between houses, it flows over into adjacent ditches and waterways. And so these 2D modeling tools really help us capture how the water moves through the floodplain. And if you go to the next slide, we'll kind of see an animation here. The other great benefit of these 1D, 2D models is they capture the full range of the flood as it rises and falls. So whereas maybe in the past you typically look at a snapshot in time of the peak elevation in a given area, now we can look at the rise and fall of that water and not only where it floods, but also how long. So as we look at areas that get underwater, structures that get inundated, we know that's going to occur for, they're going to occur for 3 hours or 6 hours. And so that helps us identify the flood risk as well. An important thing to point out here too, just in terms of visual representation, here, these roads are not actually over top. Kind of, you see the blue going through those roads. That's actually the water going under the bridge. So there's still some interpretations as you look at this data. So feel free to ask questions as we get to the end. But that kind of sets the stage for the work that RPS has been doing. And with that, I think I'll turn it over to Luis.
Hi, my name is Luis Partida with RPS. I'm serving as the technical lead. We are performing an update to the Galveston County Master Drainage Plan, which is focusing on the mainland portion of Galveston County. In coordination with the LCCD project, the county is developing the Dickinson Bayou model, whose overall watershed is outlined on this slide in black. A portion of the watershed extends into Brazoria County and is included in the overall watershed analysis. We will be discussing the methodologies and showing some preliminary results in the following slides. Next slide, please. This map shows the 79 sub-watersheds delineated for Dickinson Bayou, as shown in green. A watershed's boundary is defined by high points in the terrain or structures such that runoff generated within each boundary will not extend into another boundary unless a large hypothetical storm occurs. For hydraulic modeling efforts, these are further subdivided into sub-watersheds shown in the exhibit. Once delineated, each watershed was analyzed to calculate its unique hydrologic characteristics like the time of concentration, detention provided, percent impervious, and loss rates. Next slide, please. Utilizing those sub-watershed boundaries previously shown, the hydraulic modeling boundary was determined and used to analyze the extent of inundation. The boundary is shown as the gridded graphic on the screen, which we refer to as the 2D mesh. The 2D mesh allows for runoff developed from sub-watersheds to travel over time to the tributaries and then the main stem of Dickinson Bayou, which are represented by 1D cross-sections connected to the 2D mesh. The 1D cross-sections are shown in green and are a series of elevation data points representing the underlying terrain. The interconnectivity of the 1D cross-sections with the 2D mesh post-simulations allows for detailed hydraulic outputs, which are comparable to previous FEMA outputs with the addition of extended inundation boundaries shown in the mesh, as well as time-based results similar to what Jim was showing on the previous slide. In the past, inundation or flooding extents were limited by the length of the 1D cross-sections, and if excessive lengths were required to span the floodplain, the risk for potential inaccuracies increased. Next slide, please. The Atlas 14 100-year maximum inundation extent for Dickinson Bayou shows higher inundation levels at and around the tributaries of Gum, Benson, Magnolia, and Borden Gully. The modeling simulation also considered the tidal influence of the confluence with Dickinson Bay. Again, these are our preliminary results for the 100-year NOAA Atlas 14 inundation extent. Next slide, please. Shown here is the Hurricane Harvey simulation, which was greater than a 100-year storm. Real-time rainfall data was processed into our base hydrologic model to calculate real-time peaks and lows that occurred during the actual storm. These peaks flows were then input into our 1D, 2D hydraulic model and ran for a 5-day simulation in order to capture the full extent. During Hurricane Harvey, a less than 10-year surge occurred at the confluence of Dickinson Bay and was reflected in this hydraulic model. The maximum inundation extent for Dickinson Bayou shows higher inundation levels than the 100-year results at and around the tributaries of Gun, Benson, Magnolia, and Borden Gully. And with that, we'll turn it over to back to Brian.
Awesome. Thanks, Luis. Appreciate you sharing that. And just to reiterate the importance of bringing in the model information from Hurricane Harvey, we need to validate that again, our model is not only precise but accurate, right? And so bringing that real-time rainfall data in and running the model for Harvey helps us do that. So that is the first bullet there, which is a complete QA/QC and model calibration. Now that we've pretty much gotten that complete. I know Luis and our team have been working on that hard just over the last few weeks, actually. We are on to evaluating the mitigation concepts. So that brings us very near the conclusion of phase 2 and very near what's really restarting phase 3. We had begun phase 3 before in parallel, and now that we have the model, we can begin advancing these concepts and evaluating them with the model, which is, at least for me, one of the exciting parts of the project. We're getting close to the solution sets at this point. So let's talk first, the way the water flows is a function of topography. So this is a heat map showing high and low elevations. So on the left side of the screen, on the west side, we've got kind of a white color, then yellow, then green. That's the high ground. You can see it starts to go down, right, and becomes red, and then yellow, and then a darker red, and then almost a pastel red, almost a pink as it enters Galveston Bay. So the water wants to flow from west to east, which isn't surprising, right? That's how the main stem of Dickinson Bayou flows. What's interesting about this map, and it coincides very closely with the flooding that happened during Hurricane Harvey and what's predicted from the Atlas 100-year storm event by the model, that you can see along Highway 3 on east of I-45 that we've got a kind of a ridge that exists. You can go back to the previous slide, please. A ridge that exists there. It creates a bit of a bowl effect. Was bounded by I-45 on the west and Highway 3 on the east. That area has got a lot of tributaries joining Dickinson Bayou and no real good way for that water to get out, because that ridge on either side of the bayou, which even though it's not very tall, does tend to prevent overland flow from flowing, right? And it collects there in that low-lying area and led to a lot of the flooding that we showed on some of the previous slides. You've got a very flat and sloping area on the west side that then goes into that area as well. So the next slide talks about how we've broken down the bayou by reach. So these are arbitrarily defined by us. This is not a FEMA designation or anything from the Army Corps. But we wanted to make sure we could designate areas along the bayou because it's a pretty long reach. That when we talk about concepts, we're talking about concepts in different reaches. So we'll start the upstream side, which is shown in green, which we'll call Reach 1. Reach 1 is north of FM 517. So right now, that area is predominantly rural areas. There are some low-density residential areas in there. But as you guys might be able to see on the map, there's a gray line with a 99 on it. I think most folks on this call will know that that is the potential route for the Grand Parkway. So obviously, if that Grand Parkway is built, it's going to dramatically change the land use in that area. And so that what is a mostly low-density or agriculture area now will change dramatically, which obviously has impacts on the bayou downstream. That Reach 2 is FM 517 to I-45. And so you see that there's actually two bayous delineated. That is, there's a main bayou on the west, and then there's a bypass channel, existing bypass channel on the east. We've got both of those called out there in a section there in the middle. So Reach 2 gets us to I-45. You start becoming suburban. You've got quite a few residences that line the bayou on either side. Folks that have docks and water access on the bayou. And then Reach 2 stops there at I-45. And then Reach 3 starts at I-45 and continues all the way out into Dickinson Bay and then to Galveston Bay. So you go through heart of Dickinson along what is at one point was heavily used a shipping channel for barge traffic. So we've got 3 reaches, all about the same length, and those are kind of distributed by different transportation corridors. You go on to the next slide. So we've got some of our concepts here, and these are what we've brainstormed to date. This, I will say, is not necessarily everything that could be. So if you have other ideas, as we talked tonight about things you thought about since Hurricane Harvey, please share those with us. But we've got projects coded here, some in blue and some in red. So blue are mostly conveyance solutions. Red ones are mostly detention solutions. They're coded by reach. So you've got, these are all DB, because we're all Dickinson Bayou. Reach 1s are DB1. And then we've got, within those reaches, they're coded by alphanumeric, ABC, and so on. So conveyance solutions are important. We're trying to move a lot of water from the west to east. You can go back to the previous slide just for a second. Trying to move a lot of water from west to east. We have detention solutions right now, predominantly in the upper sections. Detention generally is more effective in the upper part of a watershed, trying to hold back that flow before it flows through and let it out slowly. There is one detention solution in the eastern part of the watershed, in the downstream section, as part of a conveyance project. But detention by itself is generally most effective upstream. That's why you see that happening there. honestly, as we look at all this, no one solution is going to solve the problem. So when we look at the reaches, when we come back to you in March with here's what we think we should do on Dickinson Bayou, I expect what we'll tell you is that we're going to do this in Reach 1, we're going to do this in Reach 2, and we do this in Reach 3. It's going to be a suite of solutions working together to mitigate flooding along the entire bayou. So we want to walk through a couple concepts that we've been talking about. We're not going to have time to walk through all these tonight, but a couple of concepts we've been talking about to give you a little bit of a feel of the scale and the types of projects we're thinking about. So we'll start in the downstream end. This is a project that is a bypass channel, which is shown in white here. So you've got the green line is Dickinson Bayou. The yellow lines on here are tributaries to the bayou. And so you've got I-45 here on the far left side of the screen. The white line is a proposed bypass channel, about 27,000 feet long, that will take water and act as a straw to take water out of that bowl and take it and deliver it downstream into Dickinson Bay. This area right here currently got a lot of tributaries coming in and not a lot of way to get the water out. So we want to provide an opportunity for that water to escape through a bypass channel. So the bypass channel would look pretty similar to what you see in the region for canals for moving water, whether those are raw water canals currently. This would look similar. It's something that would probably only have a lot of water in it when it was flooding, right? It's not going to divert the bayou permanently, right? This is not a permanent bypass. This is a flood diversion. So we're thinking at this point. And it's possibly that first segment there right along Dickinson Bayou could present an opportunity for a recreational amenity. And that's one thing we want to think about is not only how can we prevent structural flooding, but how can these projects benefit the community? So go ahead and go on to the next slide. So we're walking our way west. You see in the upper right-hand corner of that picture, you got the white line, which is our diversion channel. This section of the bayou is interesting. You know, as you get west of FM 646, the bayou has a lot less structures on it. But east of FM 646, there's quite a few homes right along the bayou that have docks and things. So the conclusion we've come to up to this point is that, you know, if we want to do a channel improvement and increase the capacity of Dickinson Bayou, that is probably most suitable west of FM 646. As you approach FM 646, because of the density of structures along the bayou, that would be a very disruptive project. And we are proposing potentially a bypass channel that would cross I-45 and then connect with the other bypass channel downstream. So all of these products at this point are conceptual in the sense that we know we need more conveyance, right? And the question is, how can we provide it? What we'll do with these is take them into the model, build them in the model, and then run the rainfall simulations. And those rainfall simulations will show water going down the bayou and then potentially going through these channels, and we'll determine how effective they are, how big they need to be in size, and then how effective they are at mitigating the flood risk. And so what we'll probably find is that the extents, the in and out locations may change, or the concepts themselves may change, or we might have new concepts altogether. But wanted to share kind of what we're thinking on a couple of these. So those are both conveyance solutions. The last one is in Reach 1, and this is a detention solution. This is north of FM 517 in the section of Dickinson Bayou where it actually currently has a bypass channel. So at this point, we're trying to provide detention to prevent flow from entering the downtown Dickinson area as quickly as it does currently, right? So we're detaining flow in a detention pond. That pond is located along the bypass channel. We set it back away from FM 517 because that property right along the road frontage is likely to be very valuable. Want to retain it for future development. But we need to provide detention in the system, right? So this detention would be located there. Like other detention ponds we've seen, they may have a small wet pool, likely predominantly going to be a dry pool, and then would fill up during a storm event. All right, go ahead and go on to the next slide. So I wish we had time to go through all the concepts in great detail, but there obviously are more than three we're looking at. Those are just kind of a flavor of the types of projects we're looking at for this stage. So comprehensive evaluation, what does that mean? That means that certainly we're going to look at capital cost, right? And certainly we're going to look at flood damage reduction. But there's other factors that matter on flood control projects. This is not all about benefit cost ratios. That's certainly an important metric, but we want to make sure we look at what we call non-cost factors, as well as number of people and critical structures that are affected by projects. So here's a table. This is an output of a meeting that we had with some of the stakeholders earlier this year. And the discussion in that meeting was what else besides cost is important. to you, the stakeholders, and to the community. And so we have 5 factors there: land acquisition, community impact and aesthetics, operations and maintenance and resiliency, other agency coordination, and then speed of implementation. So what this table shows is that we've got 4 factors that are kind of, we'll call top tier non-cost factors. How much land do we need to acquire? That obviously has a cost, right? But also has an impact to the community, particularly for having to buy homes and things. That's an important factor for non-cost. The community impact and aesthetics, which dovetails 2 things. One, it talks about how impactful is this going to be during construction, right? How disruptive will it be during construction? And then what kind of things can it provide post-construction that could be a benefit to the community aside from just flood risk reduction? Well, the category for operations and maintenance and resiliency, we want these structures, in all possible, to be passive to operate. We don't want to have to use pump stations. We don't want to have to use gates that are activated. We want the system to work on its own, because systems that work on their own have less things that can go wrong during a storm, right? We wouldn't want a system that is more complicated to operate, where things are more complicated to operate, become more difficult to operate during storm events, because that's, Murphy's Law says that's when things become difficult. So we're prioritizing products that are passively operated. How many other agencies need to be coordinated with was not as highly rated. I think we all came to the conclusion that in most cases, because of the scale of projects we're talking about here, these are all going to be pretty complicated projects that are going to have a lot of people touching them. But how many, do we have project recommendations that can be completed by a single entity? Say, could the city of Dickinson do something that has a big benefit? Or do we need to have a coalition of entities like Galveston County, Army Corps of Engineers, City of Dickinson, City of Lake City, all working together? The fewer entities, generally sometimes the faster things can come together, but maybe not as big a benefit. On speed of implementation, we hear you. We're all here in Houston. We know that every day that we're not doing flood control solutions, not moving dirt, is a day that we are at risk of flooding, right? This evening, we have a tropical storm coming aground in Louisiana. We've been fortunate this year that most of those have headed that direction. I know that I had 12 inches of rainfall at my house during Tropical Storm Beta. So we are at risk, and so the faster these solutions can be implemented, the better. So that's what the non-cost factors are looking at, trying to go beyond than just the benefit-cost ratio to help us in our project prioritization. The lowest cost alternative may not be the best solution for the community in the region, and these factors are going to help us determine that. I can go to the next slide, and we'll have Luis come back and talk a little bit about one of the tools we'll use for determining that damage, those damage centers.
Sure, thanks, Brian. So what we're looking at here is the inundated structures heat map, which was created for the 100-year event. This map was created by relating building footprints to the 100-year inundation extent and reflects the density of inundated structures based on the amount of water that it took on. As previously discussed and shown in the Atlas 14 100-year results, most of the inundation occurring was in the northern tributaries of Gum, Magnolia, Benson, and Borden Gully, and it is reflected here in the heat inundated structures, where you can see flooding north of FM 517 in the northern tributaries.
Thanks, Luis. And Jim, talk a little bit about how we'll take that data and turn it into project benefits.
Sure. So one of the things that we did early on to kind of help wrap our arms around how big is the problem, how big are the flood risks, is we took a look at just the total value of structures that were in kind of an early approximation that we had of the new 100-year floodplain. And this is just this $2.9 billion that you see here. It's just the total value of the property and the structures in that floodplain. So that just kind of tells you. That doesn't mean that if a 100-year flood happens, that that's the amount of damage that occurs. That's just what does the 100-year floodplain touch in terms of property, and that's the value. So obviously there's a lot here that needs to be protected from flood risk, and it helps sort of kind of wrap our arms around this problem. So now that we have these models done, what we're going to do is start evaluating these projects, and what we use is kind of a depth damage curve. So we know that as the structure is inundated, if it gets 2 inches of water, if you get 2 inches of water in a house, you get a certain amount of damage. As that depth increases, that damage escalates to a point at which that structure is completely a total loss. So we use that relationship of depth and damage to estimate these costs. And one of the things that we also look at as we look at these potential projects is we look at kind of the lifetime of that project because of what kind of benefits it can bring. So a typical project is going to have a 50-year design life from an engineering standpoint. And so as we look over that 50-year period, let's say the net present value before a project over a 50-year period, and we look at the frequency of storms that you'd expect to see over 50 years, you might have $1.7 billion of loss. Now we'll throw a proposed project, or maybe a couple of these proposed projects that Brian discussed in. We look at that new post-project value, and we say, oh, it only works out to $1.4 billion. And so you can see that that project has a $300 million benefit over its life. And so that, again, is another better way for us to quantify the cost benefit of these projects as we evaluate them.
All right. Thanks, Jim. So where do we go from here? We've done a lot. Got a lot of new information, and that hydraulic model will have a lot of uses for the entities in the region besides just our study. But where do we go from here? Go on to the next slide. We'll talk about kind of the milestones that we have coming up the rest of the study. So October's got a couple days left. So we'll have the model finished, go into QA/QC and calibration, get that completed. We'll re-kick off, as we talked about, the concept evaluation, looking at what we've brainstormed to date, looking at the model itself and seeing what it tells us about areas that are problematic, areas we need to focus on, and solutions that may benefit that area, whether it's detention or conveyance or both. We'll take feedback from this meeting and incorporate it into those concepts. A big part of this project is, once we recommend a solution, it's how do we go to the next step? What is the next step? So we'll have a report included as one of the submittals about recommended funding mechanisms, and then we'll have a final report presenting our findings and recommendations in March, and we will have another round of public meetings to present those conclusions and findings, one that will go into quite a bit more detail about the projects we are recommending for Dickinson Bayou, what they look like, the impacts it will have, and obviously the benefits that the project will have in the region. So we'll go on to the next slide, and we'll kind of show kind of visually where we're at on the chart. We've shown this figure at the previous public meeting. So we had the phase 1, right? We got the public feedback. We are now at the end of phase 2, right? And then phase 3, which we already kind of kicked off ahead of time, we'll come through there, talked about funding opportunities, recommendation and prioritization. We may have a situation where we recommend more than one project, right? And that we'll do our best to prioritize those so we can get the biggest bang for our buck up front. And then finally, as I mentioned before, community engagement, public meetings, and stakeholder meetings to make sure that what we're recommending meets expectations of the community and solves the problems we're trying to solve. So with that, I'll turn it over to Rachel and Connor, and we'll have an opportunity now to have a few minutes for questions and answers. So I'll let those guys run moderator on that, and we will look forward to hearing from you. Appreciate you attending this evening.
That concludes the presentation portion of today's meeting. We will now begin the comment and question period. Questions submitted through the WebEx events chat feature will be responded to verbally by the project team following the presentation. We ask that you support us in conducting a respectful, orderly, and courteous meeting. We want to be sure that we can respond to all of your questions, and we need your cooperation to do so. Here are a few ground rules for the meeting today. Since this presentation is being held virtually, we will keep all participant microphones muted to avoid background noise. When submitting your question or comment via the chat feature, please spell out your first and last name. Public meeting will adjourn at 7:30. We can begin answering the question and answers. The first one that came up is, will tonight's presentation be available after this meeting? We are going to record this presentation, and it will be available after tonight's meeting on the website at www.leaguecity.com/LCCDB. The next question is directed to the project team. Are Galveston County and the city of Dickinson involved in this study?
Yes, I think we have a couple of the folks on the phone. I think they're not in presenter mode, but I think I saw Michael Shana on the line from Galveston County, and we've been working with Chris Hurd from Dickinson as well. They've been part of the stakeholder engagement we've had.
Okay. Next question. How will improvements near Dove Meadows impact the meadows of Bay Colony?
It's a good question. Georgina or John, you guys want to comment on that?
Yeah, let me start. When we look at, so League City went through and has a separate bond program looking at systemic issues within the different local subdivisions. And as we look at those projects, our goal is to improve drainage within those targeted areas, Dove Meadows, for example. And while we do that, there's a fundamental part of that process is we can't do any harm upstream or downstream as we make improvements within that watershed. So that's a core piece and a core piece of the evaluation that those different design teams will look at.
Okay. Next question is there a model that can calculate for new impervious surfaces that would add water to the bayou and watershed?
Yeah, it looked like Jim started answering that question in the chat, but future conditions are important to understand. We certainly wouldn't want to recommend improvements and then have those improvements washed away because of changes in impervious area. Jim, do you want to elaborate on that a little bit?
Yeah, sure. So typically our models account for impervious area based on the land use type. So for the residential area, a certain density of residential or commercial areas, we may assume a certain square footage of impervious area per acre. And so while it is possible to account for impervious area in more detail in hydrologic models, it's typically not done unless you're doing kind of a very, very small detailed analysis, just because of the effort involved to compute the actual square footage of all the various structures and concrete sidewalks and things like that.
Yep. Thanks, Jim. And one of the interesting things about this hydraulic model is it does take a very significant amount of computing power to run. And so what we've tried to do is maximize the detail without overloading the time it takes to run a simulation. And we've got some very fast computers and even cloud computing that can help us do that very quickly. But if we get too much detail into the model, it becomes can become unstable and difficult to run quickly to evaluate concepts.
Next question is, has increasing the space under the railroad bridge been considered?
Yeah, Luis, I may ask you to chime in on this one. Obviously, impediments to the flow are going to be picked up as part of the model. Do you want to comment on that at all?
Sure. Yeah. I mean, the raising and conversion of bridges to wider hydraulic openings or conversions of culverts to bridge structures is something that we will be looking for throughout this model. One thing that we did notice is that I believe the Highway FM 646, which accompanies that railroad bridge, is a subdivider within the watershed that we show that even throughout the 500-year inundation boundaries from the west tend to stay on the west and the east tend to stay on the east, and they only convey through the Dickinson Bayou main channel. So all of those things will be considered, but right now we are seeing that the main divider is that railroad bridge connected to the adjacent highway.
Luis, I think that I'm talking about the one on the east side of 45. I think that's Highway 3. I think 646 is there on the west side. But yes, you're correct. It is certainly a divider. And any of those flow impediments are something we can consider. If we change what that cross section of that bridge look like, how does that change the flow rate? And that's something the model can calculate.
Yeah, as the hydraulic opening increases, the flow rate increases downstream, and in some cases we can negatively impact downstream areas. So it's important for us to, if we open up a hydraulic opening such as the railroad bridge, that we mitigate for it before releasing it so that the timing of the watershed doesn't negatively impact downstream structures.
right? And Rachel, I'm seeing another comment in here that's related.
Yes.
I-45 also, I know there's folks have identified that during Harvey, both here and on Clear Creek, that there was a differential water surface elevation upstream and downstream. What that means is that the bridge is an impediment, right? So if we want to prevent that water from backing up on the west side of 45, we have to either widen the opening or create a bypass channel that crosses I-45.
Hey, Brian. Brian?
Yep.
When, as I-45 is reconstructed, have we used the new bridges, which are generally a little higher and wider in general, as part of the evaluation, or do we use the old?
Good, John, good question. Luis, can you comment on the bridge layout in the model?
What we've done is that the hydraulic width of the extension was picked up by aerial imagery and the LiDAR, so the overall width is within the model, and field adjustments were made based on the assessment of the structures and site photos to account for the proposed improvements to 45.
So I think the short answer was yes, that the proposed widened sections, which applies to both Clear Creek and Dickinson Bayou's crossing of I-45 is included.
Thank you.
That's a good question.
And Brian, I know we talked about impediments, but there's a question regarding construction of flow along the bayou, such as boathouses.
That is a good question. I don't, I'll defer to Jim and Luis if the model has enough, can be discrete enough to talk about the docks and things that are on Dickinson Bayou. I'm not personally familiar with the permitting process for that, but Jim or Luis, can you comment on that?
Yeah,
Sure.
I'll start go ahead, Luis.
Oh, I was just going to say that we do our best to account for structures that are permanent within the channel and floodplain, and those can typically be represented by higher friction values, which slow down and impede flow. But as far as it being a physical obstruction, that's on a case-by-case basis based on how long it's been in the waterway and if it was picked up by the LiDAR that was shot representing the terrain underneath it.
Okay, we go on to the next question is how many storms and what strengths do you assume to occur in the next 50 years?
I'll take that one. So we haven't yet done that analysis. We will look at that as we get into the project formulation. But what we do is it's based on the probability of the various storm frequencies. And so you look at something like a 2-year storm, which has a 50% annual chance of occurring in a given year, up to, say, a 500-year storm that has a 0.2% annual chance of happening in a given year. So you look at the probability of those storm frequencies over that 50-year period, and that's the basis of that analysis. But we haven't yet done that, but that'll be part of how we quantify the benefits of the project.
Next question is, are there any natural channel design characteristics being considered for channel improvements? And what about stormwater wetlands or revegetation in detention basins or along channel corridors?
Good question. So I think the answer to that is yes. At this point, everything's on the table. For simplicity's sake, what we showed on the canals were straight, and I described them as you would, Gulf Coast Water Authority water moving canals. Those are not necessarily beautification efforts, obviously, and they don't necessarily present a great opportunity for community amenities. So certainly we can look at opportunities for those to be more meandering and exhibit more natural characteristics. But the challenge we'll have is that these channels are intended, if they're bypasses, to provide flow in high flow events, right? We don't necessarily want to divert Dickinson Bayou's main channel flow. So we are certainly open to what the characteristics and the design considerations for those channels. As I think I also saw a comment in the deck here about detention ponds that are can become eyesores when they don't have water in them. So there's opportunities. There's a lot of great examples within the Houston region for detention ponds that are double as amenities, whether that's recreational fields or things. That's all part of the design. And as we get those further developed, if we find those detention ponds do add merit in the model, we certainly want to double our efforts to provide an amenity whenever we have a structural solution. So those are good comments, and we appreciate you sharing those.
Next comment is, was the permeable study done with the varying soil conditions from drought to saturation to study the hydraulics?
This is Jim. I'll try to answer that one. For the hydrology, because we're doing kind of event-based modeling, we have to sort of pick one condition. Obviously, we know that the soil conditions do vary here in Texas as we go from drought to flood and back to drought again. So the way that we try to account for that is just pick a value that we think is representative, and we use that as part of the model validation process. So if we compute answers, we look and we compare it to these historical events, and we see how that compares. And we look at a few different events that may have occurred with different antecedent moisture conditions. But we're really not able to kind of model specifically a drought condition versus a saturated condition. We try to just kind of capture what we think is representative. And hopefully that answers that question.
The next question is maintenance of the current Dickinson Bayou part of the study?
So channel maintenance, it goes into a function of how much flow disruption there is, what's the roughness coefficient along the channel banks. So that's accounted for in the analysis. But Luis, I don't know if you can comment on the level of vegetation that's included as part of the channel hydraulic assumptions.
Yeah, as far as channel vegetation and maintenance, the coefficients or represented by the vegetations are selected based on aerial imagery and what was used in the past. And then again, these values can be adjusted once we are looking for calibration. A lot of these questions regarding hydrologic conditions, dry soils, wet soils, what's important to note here is that our end product is calibrated. So while we may not be considering the best source or the all the different types of sources of percent impervious or all the different sources of hydrologic soil conditions, we do know that our final water surface elevation results at certain bridges were matching what was calculated in these storms that were historical in this region. So that therefore kind of back validates our hydrologic conditions, our vegetation assumptions, and coefficients within the riverine floodway.
All right, thanks, Luis. I think that part of the question is, I think implying that maintenance is important. Whatever is constructed, if it's not well maintained, if vegetation is overgrown, it certainly increases flood risk. And so we're certainly supportive and recommend, ongoing maintenance of the channel in advance of storm events to prevent flooding.
Hey, Brian.
Sure.
And when a kind of follow-up to that question is, so when we look at solutions, what I hear the question saying is de-snagging an option. Will it improve the coefficient in the flow through the channel? Much like the same conversation I think we've heard over the last few years is removing silt and sediment and dredging the channels. There's some benefit there, and will that either of those solutions be looked at? I assume they will be.
Yep. Yeah, the model allows us, as Luis noted, to change those coefficients and change the cross sections to account for different levels of sediment and siltation, and to change the amount of vegetation. So we can play with that and almost do a sensitivity analysis and see if that has a significant impact or an insignificant impact. And certainly if it has a significant impact, it's something that we maybe recommend as a structural improvement related to sedimentation.
Or upgrade the de-snagging efforts more frequently.
Right.
Thank you, Brian.
I think we have time for a few more questions. What role has the Army Corps of Engineers and GLO played in this study?
Jim, do you want to comment on the Army Corps participation?
Yeah, so the Army Corps has been a project has been a partner on this project since we started, and they're primarily supporting with technical assistance. They're providing technical review of the modeling, and they're also assisting with with kind of the coastal analysis component. And again, our study is focused on riverine flooding, and the solutions are focused on riverine flooding, so we're not really looking at protecting from coastal flood risk. But what we do want to make sure we account for is the appropriate boundary condition as we get to that transition zone at the bay. What sort of coastal conditions, surge elevations do we need to model as we look at these various alternatives and various storm frequencies? So they're providing some more detailed coastal modeling to support that kind of compound flooding analysis.
Thanks, Jim. And in addition to the technical involvement, we also involved the Corps as part of this project in case one of the recommendations is a project that could become a federal flood improvement project along Dickinson Bayou. We wanted to make sure that the Corps was in the loop of what we were doing and could accept the conclusions of this report almost as an in-kind effort for the Corps. So we're very, very fortunate to have them as a partner. And as we get through now the modeling efforts and the concept evaluation, we're working with them to make sure that they are fully on board with what we're talking about doing on the project.
The next question is the city of Nassau Bay involved in the study?
I'll answer that if you don't mind. The city of Nassau Bay has been certainly a financial partner. They have participated financially. They want to be engaged in it. I don't know to what level technically, but yes, they're a partner in the project.
Thanks, John.
And I know you touched on this earlier, but the question is, are TxDOT and League City working together on the detention ponds at 646 and I-45?
The new detention ponds at 646 and I-45 are TxDOT ponds and meant to mitigate the impacts of the widening and expansion of I-45.
Okay. Does your study look at future storms taking into account the increased frequency of high rainfall events? And and also is storm surge accounted for part of the study?
Okay. So with regards to future storms, for the rainfall, there's really a great deal of uncertainty in terms of how we estimate rainfall frequency already. Obviously, we've got a lot better data now with Atlas 14, but it becomes very hard to predict how rainfall frequency is going to change in the future. Obviously, we know that it will. It's very hard to predict that. So we're not varying the rainfall as we look at future conditions in the watershed. However, one other thing that the Corps is looking at is future sea level rise as we look at this coastal boundary condition for our models. And so there will be some analysis to take into account sea level rise in the future. But predicting the future differences in rainfall frequency is very hard, and there's just too much uncertainty for that to be a very valuable effort. And then on the storm surge question, again, because we're focused on reducing flood risk due to rainfall events in the watershed, we know that for extreme surge events like Ike, none of these improvements that we're talking about are going to impact surge. So there's a whole separate suite of projects that are being looked at in Galveston Bay for protecting from storm surge. So it's really not part of our analysis. Obviously, we know that's a flood risk, and we'll look at different types of storm surge as far as how it impacts our projects. But the projects that we look at really do not provide any kind of benefit.
Yeah, let me just do a plug. When we started this project, there are two types of flooding clearly within the watersheds. It's the riverine and the storm surge. I think most everybody in this meeting, recognizes that there's I'll say, parallel effort that's been going on, frankly, years before we started this, the coastal barrier. That's an active project from the Army Corps of Engineers, and frankly, that's still our belief as to how storm surge will be most affected or most the most protection will be through that process. I would encourage everyone on this call to participate in the meetings the Army Corps has scheduled for the next 30 to 45 days, and look forward to continued support of that project to keep it moving forward so it doesn't get stalled out. I think there was an article in the Galveston Daily News today about that. And again, that's what we see in Lake City is really the storm surge solution to address issues in Galveston Bay and up Clear Creek and Dickinson Bayou.
Yeah, thanks, John. We are looking at downstream conditions for the big rainmaker storms. So we seem to have two different kinds of storms. Storms that have a potential for a very large surge, storms that drop a lot of rain. Storms drop a lot of rain do have some surge impact, but not nearly as much as the big wind storms that push a big surge in. So we do, obviously, Tropical Storm Beta had some impacts, some surges. Harvey had some impact from surging to so much water in the bay. So we're not assuming a downstream condition of 0, right? But we aren't necessarily assuming a surge condition, a maximum surge condition either.
Thank you, Brian.
Yep.
At this time, we've gone through all the comments and questions in the chat. The time is after 7:30, and just as a reminder, if you have additional or follow-up questions, please submit your comments or questions in writing through mail at attention LCCDB Study Team, care of Holloway Environmental Plus Communications, Inc., 2500 Summer Street, Suite 1130, Houston, Texas 77007, or filling out the comment form attached to this meeting. You can send that in through email or through the online form on the project webpage, which is www.leakcity.com/LCCDB, or you may email the project team at lccdb@leakcity.com. We thank you for your participation today and the interest that you have shown in the study. The public meeting is adjourned at this time.
Thanks, Rachel. Thanks, everybody, for attending.
Thank you.